Next we have a presentation by Javier, who is mainly a developer, but he does have some experience with teaching, actually quite a bit of experience with teaching. And he is going to have a talk about teaching Python to Gen Z, bridging the gap between file systems and AI-powered applications. How many of you are Gen Z in this room right now? Can I see a raise of hands? Okay, we have some. So the rest, you are going to listen, and then you will know how to teach these people who raised their hands. Let's just see if Javier is getting a good setup. Yeah, you good? Okay, so let's welcome to the stage Javier.
Hello everyone. I don't know if you can hear. So yeah, I teach in high school, apart from being a Web3 developer. And I have been teaching for already 5 years, I think. At the beginning I was teaching only programming, but I also teach engineering-related courses in general. So, I will try to focus more on what are key takeaways for developers from teaching, and not on how to teach programming. If someone's interested, we can talk also about that later, but I will leave the pedagogical stuff for another time. An interesting thing that happens with Gen Z or like young people right now, on disclaimer, when I was yesterday talking with a former student and talk about the talk, she said to me, "But you're also Gen Z." I'm actually on the board the first year of the Gen Z. But one thing that happens is that they have the problems navigating the file system. So they save in their IDE a file, and they don't know where it is saved, and they don't know how to reach it, and they don't know like what to do with it. So we have a lot of really cool tools on how to teach programming, on how to online put your code, debug it, whatever. But they struggle with something like finding a file, uploading it to the right place. It seems stupid, but it's what actually happens. At the same time, some of them end up starting a startup at the end of the high school time. I will talk also about it. And many of them do like pretty cool projects at the end of the high school. So how does this happen? That they start struggling with file system, they end up doing a lot of cool stuff. Well, AI has a lot to do with it, but it's an interesting phenomenon. So I will try to give some takeaways on understanding how the younger generations are using AI and what are the good things, the bad things about it. Also spotting some patterns in junior code or in junior way of thinking, because I think that's the most important thing, understanding how a junior developer is thinking about the code and how he's approaching the solutions. And well, mentoring. Like, big problem is always how we interact with people, with developers, how we work together, how we make that symbiosis a good cooperation, let's say. As I said, basic computer literacy doesn't mean code literacy. They might be doing a lot of code, writing a lot of code, but struggling with simple things, which is very interesting. Of course, that has a lot to do with Googling things that already happened before having AI. Stack Overflow is everybody's best friend. Now it's AI, but pretty much the same idea goes there. It's also interesting that they also kind of mix up what are variables and parameters, but what is the difference between the print and the return functions in Python. So we will dig a bit deeper into those topics. So as I said, like for instance, the Walton case, this is currently a startup in Estonia. I'm not seeing Andy, but I guess somewhere here. But these guys started doing their project in the last year using AI to code a dashboard for automating a smart light that would turn on and off itself according to what is the electricity price in Estonia, and therefore saving money from the different appliances at home. Now they actually have a working product. They have like a better application. This is like the first prototype they did in high school. Now they're actually like selling products and selling services and pivoting continuously, which is nice to see. And they have kind of changed a bit the topic, but it all started by using AI for their final project in high school, and they barely understood what they were doing at the beginning, but at the end of the project they actually knew how it worked and how to make it work, and they got really good experience that made it possible to start a company after that. Some other projects that are quite interesting to see is for instance, what we did in the engineering camp. We have every year one weekend where we do different workshops about different topics. There is usually one about programming, either web development, machine learning, whatever. And those are actually really good inspiration for the students on like to take on like challenges. So some years ago we started using MediaPipe, Google library for machine vision, and before they actually doing the workshop with them, I did a prototype to put the Chrome dinosaur working just with hand gestures. You can see that I'm actually really bad at it also. And this was the first inspiration for them to later on build themselves this same game. But it doesn't stop there, because one good thing of showing this kind of stuff to the students is that they accept the challenge, they see what is possible, they get really motivated, and later on themselves like explore. And that's a really good thing of the students, that they want to explore, they want to try out new things. So what happened that year in the engineering camp is that one of them ended up doing like a mouse control with their hands. So instead of just controlling like a game, he had like a mouse that just by moving his hand, he was moving the mouse and drawing different things in the computer. Of course, in this case not super practical, but really cool feature that they did all by themselves, like just learning the basics of machine learning. In this one actually I had a friend in the workshop. I was doing another workshop in parallel, but so I also asked one former student that is now helping me in the school with some projects, like what was hard for you and what made you understand better. So the problem is that during the first year she was struggling in understanding basic programming concepts, and when I asked again 2 days ago, she was like, actually had hard time with for loops. And I had programming class also on Thursday, and I also asked some students like, Thursday was yesterday actually. I also asked the students like, what was hard for you? And many, like a couple of them, they also say like for loops. So for some reason, for loops, especially in Python, are hard to understand. But then this student that is now actually the first one I say, she's actually studying informatics now in technical university. She told me that just revisiting the problem, like going to it from different angles, and giving it time, and as you see here, ask and search until you understand why it's not working, instead of finding a solution. So finding a solution is not the important thing when you are learning or when you are like solving a problem, but understanding why it's not working. And yeah. So another interesting topic is that, of course, many students use AI for doing their homeworks, but that's really important that in the first year they actually use it more as a learning partner than as a coding partner, because they really need to understand what are the basics, so later on they can understand why it's not working. They can also debug it, which AI is struggling with, and so it's important to see what are the key differences. And it's actually super easy to see what is AI-generated code and what is students' code. Here are just some examples of the things that just make it clear. For instance, f-strings, list comprehensions are things that we don't learn at the very beginning. So when they use that, it's very clear that either they have Googled it, and most of the time, because of the cleanness of the code, you can see that it's AI generated, because the students are never clean when writing code. Okay, which is normal. I think we should, or at least we have been there once, and or using methods that I haven't shown in class, soft typecasting, or this kind of stuff. Yeah. The problem with that is that they don't understand what they are doing and they cannot explain it. So quite often when they do something like that, I ask them like, please explain me this code. And of course they can't. So they have to go, study again, make a simpler solution, something that they actually can do themselves, and that's very important. And then is when they can go ahead and use the fancy stuff like list comprehensions or F strings. I'm not calling them fancy is the right thing to do, but yeah. But they also love challenges. So what you can see in that picture is a 4-bit calculator done with logic gates that we also did in one engineering camp. And that year, but many times the topic of the workshops are something that I would like to do and I have to explore, so I usually prepare it, have fun myself, and then give to my students. So I wanted to see how to make a 4-bit calculator using transistors and then logic gates. And I thought, this is gonna be super hard for students, probably they're gonna feel super demotivated and not arrive to the end. Because when I did it myself, I spent several hours connecting cables. It can be fun if you're kind of in that part of the spectrum, but I can understand that not everybody likes that kind of stuff. But I was really surprised when they were super into it, and they did it very fast. And they were just reading the schematics, understanding how the connections have to be done, debugging it, because it's super easy to make mistakes when wiring these kind of schematics. And it's like, where is this cable going? So they have to understand that they have to be very clean for it. My point being with this is that when you throw them challenges, things that are actually challenging their understanding, they go into it. And that's a really good aspect. Because often we are like, okay, do this task, you have to do this, and this, okay? Or you have to take this. And when we give free hands to arrive to somewhere or to achieve some goal, they actually manage it if they feel that it's something challenging, something that they can learn from, or something that is interesting. And so yeah, we ended up having 5 lets to show the 4 bits plus the extra bit, so you can sum up to 16, which is not a very high number, but it's cool when you have built it completely from scratch. And they understand what are the very, very, very basics of computer logic. Experimentation also has its boundaries. What you see here is the process of an electric motor that is completely burned down or melted down. We have also electric cars in the school. And one day, the 10th graders, they decided that, okay, we are not going to ask Javi, we are just going to go and drive the car. So they went to the workshop, they took the car out and started driving for 2 hours with the guy that weighted the most. So what ended up happening is that, of course, the current was not super high, but the motor heated up too much and ended up melting. Like, as you can see, there is like a red cable there that is broken, but also the process are completely off, which I thought it was not possible. But they demonstrated that it's possible if you don't know what you are doing. And I remember when I talked with them the first time, I was like, I don't want to encourage them to do this, but at the same time it's cool that they're experimenting because that's how they learn the most. And actually for me I was super interested that we had to open the motor and see what happened and how the process actually broke. But I think also part of encouraging this experimentation is also setting up the boundaries. You cannot experiment with production code, of course. So it's also good that we have well defined where are the boundaries of where the experimentation can be, but it's also good that we create those spaces for experimentation, that we have like a test development or a like really local development environment, whatever, but a place where everything can be broken and it's fine, and we have to be fine with it. One interesting thing that happens in high school is that you see a very basic problem, or I give them very basic exercises, and you think, this is super easy, I cannot see if they have copied from each other, because they're gonna have the same solution. And that's actually not true. Even the simplest problems have dozens of solutions, which is very interesting because also helps you understand how other people think. So if I put this problem, exercise, print even numbers from 0 to 10 to 100, how do you think you would solve it? And I'm gonna show quite many different solutions, but I bet that someone here is gonna think a different solution from all the 20 or how many, whatever I put here, which is super interesting and fascinating in my opinion. Of course, there are better and worse solutions. That's something that we all know, but there are many different solutions, and there are some that are as equally good as others. So the basic one, just having a for loop with range starting from 0 to 110 with a step of 2. And this is something that they understand. Like for instance, yesterday I had class specifically about for loops. That was the first class with the 10th grade, and this is what we ended up doing. So this was the solution. But actually, one student before I was showing this had already done this, which is also completely valid, and it's also very easy to understand. But we can get fancier and obfuscate things more, and just, I forgot the print part here. There should be a printable at the end that will actually print the whole thing, but this also works as well as this. So this one, for instance, we haven't done conditionals yet, so I would expect them to do this. Like some guys that actually have been trying things at home might know, but most of them, they still don't know how to use if and else statements, so I wouldn't expect them to write it. Of course, all the rest are things that they wouldn't write, but are also valid solutions. One that many would do is a list comprehension, which I don't think is the best solution here. I think that just having a step is better, but yeah, you can also do while loops in different ways. The one that doesn't understand what the minor or equal one is. The function ones that I like more, using map functions. Then you can just even get fancier and use the bitwise operator. Also there is a div mode, that's the next one, I think, enumerating. You can actually also teach recursion with this, which is super interesting in my opinion. Using another lambda function, in my opinion this is my favorite one. And using div mode. So things like this one, the using map with lambda, is one that for a junior developer is a good test. Because if you don't put the list at the beginning, the map function actually doesn't print it. Because the map function creates a generator. And there you can test if the junior developer is actually understanding what the map function is doing. The map object is an iterable, but is not still executed until you actually make it a list object or a tuple or something like that. So that would be an interesting test also to make sure that they understand what iter tool do. You can also use iter tools, as I was mentioning, or even unpacking with print, which is probably the coolest one in my opinion. All of them do the same, absolutely. When I don't forget the print function. But some are better, some are worse. I don't know if someone thought of a different solution. I don't know if someone dares to say about it. Okay, someone actually thought of a different solution, which in my opinion is very interesting. When they struggle with things like print and return, and you see this solution, let's say, or this is their code, and you wonder, why? What's the problem? Why do you write a print instead of return? And they're actually completely different things. So for our developers, it's obvious, they are not the same. But for someone that is learning, it's not that obvious. So what we can take from this? Well, the first thing is that they are visual learners. The mental model is not abstraction. their mental model is what they see. I was talking before with Isaac that actually developers and engineers, we are corrupted. We have a very different way of thinking than normal people. And that's fine, but we have to know that we don't think the same way. And you really realize about that when you are teaching. Because students, they still have a pure mind, they haven't been corrupted, they don't think like programmers. So that's part of learning programming, is understanding what are those mental models to make it work. So that's also when you have like a junior developer, understanding what they understand, how they think, is what actually is going to make the learning process faster. Another example, when they struggle with function definitions versus execution, is that, again, they have a hard time abstracting concepts, which is okay, because we don't feel abstraction, we think about it, we understand it. And so this is a typical problem that they always do. There's many of them that they do this kind of error when we are learning functions. And it's that they have to write a function that just reads, and instead of calling the function and putting the parameter value, they actually just write the value within the function definition, which is kind of like, why do you do that? But that's the problem of not understanding the abstraction. So another better one is when they actually write it as a default parameter without knowing that they're actually writing a default parameter, which is interesting because it actually can work, of course. If you write a different value in the brackets, it will work, but they don't know what they are doing. They don't know that they have created the parameter. Their exercise had an example that says what has to happen if you write read and Alice. So they write examples within the function definition. Again, very interesting. So, what is the thing that works the best when teaching is asking questions. Don't give them answers. And that's very important because when you know the stuff and seems obvious, it's super easy to just give them the solution. Like solve it, like, hey, just put a column here. Come on, this is like stupid. Or just you forgot a bracket here, or you forgot a parentheses, or like this syntax is wrong, or whatever. But actually that doesn't help. That makes, well, as a teacher, that makes your work like, it makes a harder work because you are not solving, you are not teaching them, you are solving the problems, but they are not learning from it. And I know that they hate me for this because whenever they ask a question, I usually ask them a question back. And I know they complain about it, but then they are thankful because that way they understand and solve the problem themselves, which is very interesting. So for instance, with this kind of error, where they have an indexation error, okay, it's super easy. You actually try to execute this code and you get, okay, indentation error, unexpected indent. And okay, it's kind of obvious what you have to change, but they are still not used to reading the error messages. And I think there are still many developers that don't read the error messages. And you have to just go to traceback, see where it's going on, escalate the bug, whatever. But that's very important, because if you see a junior developer making a mistake and okay, just fix this, but then doesn't understand where did it come from, then you are not actually helping. So, don't say like you're missing a column, for instance, if it's like a colon error or a syntax error, but just say what the error message says. I just realized that I had a different example before, that's why my text don't match. But the thing is, trying to make them think where the problem is. More interesting problem is this one, where we have a function that creates different functions, multipliers. So using lambda. So we are returning a list of functions that are supposed to take a parameter that then is actually multiplied. So we can actually make a multiplication list when we have multiplying by 1, 2, 3, 4, whatever. The reality is that when you execute this, you always get 6. and it's very easy for everyone to make this mistake because you think that that you're actually creating different functions where they are taking the e parameter or the e variable, so 0, 1, 2, 3 as the parameters of the functions or the constants within the functions. But then you can ask, what value is e when its lambda is called? The question is, what happens when lambda is called? Well, e last value, if you look at the stack, was actually 3. So, or when is e looked up, when the lambda is created, when it's executed, and that's the problem. The constant in the lambda is not saved when you do the for loop, but actually when you execute it. So you are using a constant, so it's all about scopes from one hand. And but if you check the stack, if you debug it, if you open the debugger, you can actually see the last e value was 3, and therefore when you execute the lambda, you are always using 3. So whatever you write there too, you're always going to get 6. So yeah. Now I will start to sum up, and I would say that the key takeaways for this is, first of all, asking questions, never giving the solution. It's really easy to give the solution, but then we are not making our work easier, but actually harder. When we are mentoring younger people or people that know less than us, it's a key part that we ask the right questions, not that we solve the problems. JIT information just in time. When I was asking for my students, so what's actually hard, or what was hard when you learned programming with me, and they said like, you tend to give too much information. Like, you see the whole thing, and you know about what's happening behind, like what are the behind the curtain things that happen when you execute some code, and you try to prevent future problems, but actually giving too much information makes it harder for them to understand how things work. I don't know if that phrase was understandable, but the point being that giving just-in-time information, understanding how much they know is important, because if you give too much, and that's, in my opinion, a problem of Python documentation, or not Python documentation, but documentation in general, sometimes either there is too much information or too few. So it's not, which it makes sense, it also has to be general for everyone. But when teaching or helping someone to understand, you cannot do that, because they don't understand everything yet. And if you are trying to understand what happens, like actually in the back, then they are not really going to understand it. So yeah, being on the same level and kind of not giving too much information is actually good. Being patient, time is a good medicine. Actually, I realized that I had this one. Well, whatever, doesn't matter. And focus on algorithmic thinking. AI, well, can debug, of course can debug, but not as good as humans. Like, I guess everybody here has experience using AI, and how, for instance, that's a simple mistake, like forgetting closing tags, or just like giving the code in half, or for instance, inventing a variable name that doesn't exist. That's quite often the problem. And actually, as a programmer, you can spot that very quickly if you know what the code is doing, and those are simple mistakes. And also, we all know that coding has become super fast with AI, but having the critical thinking and understanding is still very important, otherwise it's very hard to debug. So possibilities, then let them explore. As I said, when you give them free hands, it's actually super fascinating what they can do and what they can achieve. Know what shouldn't be break. Where are the breaking boundaries or the experimentation boundaries? Also creating the good sandboxes, it's very important. Like having a place where you can test things, where you can break things, I think is key for development, especially when you're taking new developers into the team. So I think that's all from my part. If someone is interested in talking more, that's my LinkedIn. I don't know if there are some questions, I guess.
Thank you for the talk.
You're welcome.
Good questions here. Have you experienced any language barrier when interacting with the youth due to their heavy use of slang? Are there any programming concepts that they refer to by some funny Gen Z slang word?
The funny thing is that I use a lot of memes in my presentations. Actually, I had some memes, but I was like, I don't have to put them. I didn't put. But usually in my school presentations, I have a lot of memes.
Okay.
The barrier is more in that I teach in Estonian, but they actually prefer to use English terms, which makes sense because most of the documentation is in English. So that's an interesting thing. What was the other? The use of the slang. Yeah, of course, no, I cannot think of a funny name that sometimes I hear that they use. Like, it's not that they use like existing slang, but they invent funny names for functions or what things do. But I insist a lot in explaining things like what means to iterate, what it means that something is iterable. For instance, we were talking this week what's the difference between iterable and indexable. Because at the beginning it seems like it's the same thing, they are not the same thing, of course everyone knows. But I put a focus on that, so when they actually go to the internet and they read themselves documentation or explanations, they can understand the language. Because that's the thing with AI. Like, it solves a lot of problems. I was also yesterday talking with another student that is doing a project for developing an AI application for customizing trainings. He's in the 12th grade. He was like, I don't understand what this thing here means. I think it was, DevOps, like what DevOps means. And that was like very specific. But sometimes having the same vocabulary is like the important part, like talking the same language. And so I insist a lot on like understand. They can later explain what themselves using other terms, and also try to like explain it. I have a lot of pedagogical things that I use to explain. I didn't want to focus on that because I don't think that's useful now. But yeah, it's like adapting, but then also explaining what are the official or the more academic words, because it's important to know how things are called properly.
There is a question about an experience. Okay, so there's someone who has experienced that when teaching a language to a younger generation, that they sometimes confuse multiple languages, for example Python and JavaScript, which are often taught together in the context of web development. I'm guessing this is more like a university level, like first year, maybe you also teach those both in high school. Do you have any tips on how to teach two very different languages without the students getting confused?
Yeah, so that's actually interesting. In our school, I teach the programming only in the 10th grade. Then we have another two teachers in the 11th and 12th grade. In the 11th grade, they focus more on web development, and the 12th grade more on software development. So I teach only the basics in Python, which is a good starting. I also have another course with them that is Arduino, where they use a bit of C++, but there we focus more on electronics and microcontrollers. The focus is not that much in programming. So, but it's actually good, because then they see what are the differences between languages, and they start to abstract what are the concepts. Because the syntax is one thing, but understanding the concept is more important, because if you understand what like procedural programming or object-oriented programming means, you can use that in every other language. So it's good to use like different languages. My experience is that since in the first year we focus in Python, they tend to reference everything in Python. So when later they learn about arrays using PHP or JavaScript, they just reference arrays. Okay, so this is kind of list. And then the important thing is to make the difference. Like, what is the difference between an array in JavaScript and a list in Python? But yeah, I would say that starting with one language, like focusing in one main language, is what actually helps.
Now, again, like a learning tip, like when do you think is the best age to start learning programming? And do you really recommend that Python is then the first language they're going to be learning?
So I teach Python because I like it. And also it's the first language I learned, and I think it's easy to pick up. It has the problems that since there is soft typecasting, there's a hard time differentiating what are data types. So actually I focus a lot on the first weeks on understanding what are the data types. So I always ask, so what is the data type of this variable? And then we keep going. So, and it actually works. I think that's the softer part of Python, but once that is clear, everything goes smoothly. And
the age.
The age. Depends. I wouldn't teach Python to like primary school students. I don't think that's actually gonna help. It's a bit hard because of the abstraction. But you're gonna start with like blocks, scratch. I teach only in high school, so I don't have experience with smaller kids. I once did a programming activity, like extra activity, and some of them were actually really motivated and ended up doing a Pi game for their school project. I think that was the 7th grade. So if they are very interested, you can start earlier with Python. But first I did with them Scratch, then a bit of HTML, and then finally Python. So it's just depending on the age, they need a lot more visual. Also, one thing that I do with the students is using the Turtle library at the beginning, just more for motivation than for actually like learning purposes. I was thinking about putting that. I always ask them to do a creative work where they have to draw something in Turtle, using Turtle library, and they do really cool stuff.
Yeah. So you mentioned like there's already a lot of your students who are doing some cool stuff with programming. So do you get a sense of hope for the future from the
definitely yes. The first students I taught in high school, they ended their bachelor this summer, actually. So I'm seeing the first ones that have also ended up university. I mean, as I said, some of them straight away from high school, instead of going directly to university, did a startup and they are doing it successfully. But also see others that are in high school doing some cool projects. I know there are some people from PipeDrive, and I know that some of my students are already in PipeDrive working there, and actually with a good job. So there is definitely hope, yeah.
So they see programming as a viable career option.
Yes, and they are interested in it. So it's. I say that they are very visual, but there are also a lot of nerdy students, which I think is good. I call them nerds myself in class. I said, you're not the normies, you're the nerds, and that's the good thing. And they are actually exploring a lot. Like, some of them use pretty fancy CLI applications. Many of them don't have Windows computer, they have some Arch Linux or Ubuntu, whatever, like different distributions. And they are not afraid of doing like hard stuff. It's just if they have to like the challenge and go for it. Like I know some of my students have already their own server during high school time, and they have their own like mail server, and they're like. I remember 2 years ago, one student that is now in university, when he submitted his homework, he was sending me links to his file server instead of just uploading the file, which I found interesting. And I was like, I need to upload it, and he was like, what's the difference? And I actually accepted it because he knew the stuff pretty well.
Nice. Any more questions from the audience? Something? I guess not. So thank you very much. It's really interesting, and enjoy the day.